Welcome to Getting Started with Ease Focus 2, a video tutorial that will give you a first insight about this valuable tool developed by AFMG. Ease Focus 2 is a 3D acoustic simulation software program for the configuration and modeling of line array systems and configurable loudspeakers. With this tool, the user can quickly predict the performance of sound systems in a venue and adjust it to obtain the best results. The software is free and can be downloaded from the AFMG website. To install it, just unpack the downloaded zip file and double-click Setup. This will launch the Setup utility that will install the program in a few easy steps. Upon startup, the software will prompt you with a question if you would like to sign up for the AFMG newsletter in order to be informed about program updates and other AFMG news. We recommend that you subscribe to the newsletter. It will only take a minute. Focus ships with a number of language options. Normally, at first startup, it will detect the language of your operating system and use it automatically. But you can also choose your preferred language in the options menu. Let's take a look at the software interface. On the left, you will find a window with the project properties and the object properties. In the center is located the top view, that is the horizontal coverage. This is the main place where we will insert, select, and modify the objects. And on the bottom is the side view, the vertical coverage. It will show a vertical section of the project, referring in general to a selected object. Some objects can be edited here as well. Other tabs are frequency response, levels, and distribution. On top of the window, we have the Ease Focus logo, or the manufacturer logo when a sound source is selected. Just below is the mapping toolbar. We will need it later when we activate mapping. Note that you can freely move and resize the windows. You can get back to the two default layouts from the View menu. And you can also store and recall your own layouts. This is the project we are going to build in this tutorial. When building a project, the first step is to define its properties. This is accomplished via the Project Properties window, where you can insert basic information on the project, as well as some settings that are relevant for calculation. Let's keep default settings here and click on Project Settings. In this window, you'll find selectable ear heights of the audience at which calculations are performed, and default height limits for sound sources. Set the upper height limit to 12 meters. This is the ceiling height of our theater. And in the lower height limit, insert 6.5 meters, which is the stage height. After defining project properties, the next step is inserting audience zones in the top view. An audience zone is a surface that roughly involves the audience and can have different shapes. They contain one or more audience areas that are the actual areas where the audience is located. We will start with audience zones for the moment. There are various ways to create them. We will try different approaches. Let's exploit the rectangular audience zone in the default project and modify it so it can be the stage. Double-click the zone to see its properties. In the Object Properties tab, you can edit the selected object, or if no object is selected, you can see a list with all objects contained in your project. In our case, we only have this zone so far. Let's get back to the zone properties. Here, you can edit some parameters of our audience zone. Our stage is 8 meters long, 14 meters wide, and is located 10 meters from the origin. Next, we have to adjust its orientation. This yellow arrow indicates the viewing direction of the spectators, which is in most cases pointing towards the loudspeakers. This means that the arrow of this zone should point to the opposite direction. To fix this, In the orientation field, insert 180. Alternatively, you can right-click the zone and choose Flip Horizontally. For our future reference, change this zone's label to Stage Zone. Note that you could have changed all those parameters by dragging these little handles and the zone itself to move it freely in the top view. All drag actions snap by default to the displayed grid. If desired, it can be changed in the options window that can also be opened by hitting F9, Grid and Snap, Object Snap. Holding Alt key will also temporarily deactivate the snap to the grid. By holding the Shift key and dragging with the mouse, it is possible to measure any distance in length and time delay. At any time, you can adjust the zoom using these three icons. To create the center left audience zone, select the right angle trapezoid and click or drag with your mouse. Note that the orthogonal side should be on the left side. In the object properties, change it from right to left. Or right-click on the zone, flip vertically. Next, insert these parameters. As you can see, the orientation is already correct. Let's call this one center left zone. To insert the left zone, we'll use a different approach. Open the options menu. In the grid and snap options, you can see that the grid size is currently set to be dynamic based on zoom level. Change it to a fixed value of 5 meters. Now, independently of the zoom level, the grid size is always 5 meters. This is a helpful feature to move and resize some objects, as we will do. With the right mouse button, click on the center left zone and select Copy. Then, click again and select Paste. Copy and paste can be used with all types of objects. Flip it vertically and drag the zone until the sandal snaps with this point. Now, drag the sandal to change the orientation until these edges match. Finally, in the object properties, displace the front center Y coordinate by 1 meter, which is the width of this ale between the zones. This is the left zone. Now the left balcony. Right-click, Add Audience Zone, Annulus Sector. Insert these parameters. Now we need to rotate it, and then place it in the correct location. We can do it in two different ways. We can either drag the sandal and rotate it to the desired orientation, and then drag the zone to the preferred location. Or we can change the orientation in the object properties. Please note that when you do that, the rotation point is the center of the audience zone. When changing the orientation using the handle instead, the rotation point is a front center point. This is a subtle and important distinction. Label our new zone left balcony. Try to insert the other audience zones. After finishing, it should look like this. Don't forget to define the labels. After defining the audience zones, we have to quickly set their corresponding audience areas. These are defined by a starting point and an ending point relative to the zone. In the side view, it is possible to modify and insert audience areas in an audience zone selected in the top view. You can also edit them in the corresponding audience zone properties. These dotted lines indicate the selected listening height that can be changed here. In this selected audience zone, call the first area front area and the second one back area. Note that in the side view as well as in the rigging and levels windows, we have the DZ coordinate system. While Z still refers to the elevation from the ground, D is relative to the object whose selection is being displayed in the side view. It reflects the distance along the object's main axis from its reference point. In the case of audience zones, the reference point is the front center point. The front area goes from the very beginning of the audience zone to a D2 equals 13 meters. The back area goes from a D1 equals 15 meters to the end of the zone and has an initial elevation Z1 of 2.29 meters. And both of them have a tilt angle of 10 degrees. The other main audience zones have a similar profile. A fast solution to define their audience areas is the copy areas operation. We can either perform it by clicking with the right mouse button, copy areas in the first zone, and then selecting paste areas on the target zones. Or by clicking on the Copy Areas button in the Object Properties and selecting the target zones. Clicking on a zone in the list will highlight it in the top view, so you can make sure you are choosing the right zones. We should copy them to the center left zone, center right zone, and right zone. On the balcony, we only need to change the elevation to 7.5 meters and a tilt angle to 15 degrees. If you insert 7.5 meters in the Z1 field, you can see that it was restricted to 4 meters instead. That's because the maximum inclination of an audience area is plus or minus 45 degrees. If we increase a little bit the Z2 value, we can now get to 7.5 meters. Adjust the tilt angle to 15 degrees. Copy this area to the other balcony. And that's it. We can now insert the sound sources, which can be either line arrays or adjustable loudspeakers, such as digitally steered columns. In Ease Focus 2, sound sources are based on system definitions, that is GLL files. The software is not restricted to a single manufacturer. Therefore, various GLLs from different loudspeaker manufacturers are available for download on the AFMG website. To add them, unpack the downloaded zip file, and from Ease Focus, click Import System Definition File. To insert a sound source, right-click, Add Sound Source, or use the Insert Sound Source button. Select the AFMG sphere line, and then left-click or drag. Notice that after inserting a line array, the rigging view becomes available on the right side. It is useful to check the dimensions and height limits of an array. This red strip, also present in the side view, indicates that the selected sound source is violating the height limits that we defined previously in the project settings. If the sound source is within these limits, the strip turns green instead. As you notice, some black lines have also appeared above audience areas in the side view. These are level lines, showing acoustic pressure levels along the axis of the selected object. In this case, along the sound source's aiming axis. You can find exactly the same information in the levels window. Here you can examine it more accurately as you have a dB scale on the left. Clicking on the scale will open the levels page in the options window. If you leave it automatic, as it is by default, it will adapt to the levels currently being displayed, But let's get back to our theater. We want to set up an LR main system in front of the stage and delay systems aimed to the balconies. Let's call this one left main array. We will start by setting its coordinates in the Object Properties window. These are the parameters needed for the other sound sources. Let's take a look at the other properties. The first parameter, setup, lets you choose between manufacturer-defined setups for the array. In this area, besides changing the position and orientation of the system, it is also possible to set specific height limits that will only be valid for this sound source. You can change the number of the boxes, their types, the angle between them, and the gain of each element. The pinpoints can either be defined here, or you can define the vertical angle and let Focus find the best pinpoint automatically. Some limit specifications, such as maximum weight and maximal tilt angle, are normally contained in a sound source system definitions. If any of these limits are violated, warning messages are displayed in this area, as well as in the status bar. Ease Focus supports line array presets. Some standard presets are available for all line arrays and can be set under Edit, Line Array Presets. Additional presets defined by the loudspeaker manufacturer are available too. The autosplay function is a valuable tool of Ease Focus that can considerably reduce the time spent on the initial configuration of a system. By activating this function, the angles between the boxes and the array tilt angle are modified in order to optimize the SPL levels in the target audience areas. Let's try autosplay on the left main array. In the top section, you can choose which boxes will be considered on the operation. Below, you can select the preferred autosplay strategy. The conventional strategy runs the autosplay algorithm with no constraints. Arcade applies a constant opening angle between adjacent boxes if possible, and the spiral applies a constantly increasing opening angle between adjacent boxes if possible. On target audience areas, you find a list containing all the audience areas that are crossed by the loudspeaker's aiming axis. Here, you can specify the areas that will be considered for the operation. In our project, we have specific delay systems for the balconies. This means that we should uncheck the left balcony zone in order to exclude it from the autosplay operation of this array. Keep default settings in the first two sections and click Start. You can see in the side view that, as expected, the balcony was excluded from calculations. In the Levels window, you can see that lines have been flattened a bit, resulting in more homogeneous acoustic levels along the source's aiming axis. We can now copy this setup to other shareable sound sources, similarly to what we did before with audience series. Right-click the source, copy setup, then right-click the target source, paste setup. Alternatively, you can select Copy Setup to other line arrays and choose the target sound sources. In our case, the right main array. The copied information will include box content types, tilt angles, and filters, along with the global tilt angle and height of the line array. Try to apply the same procedures for the delay systems. Don't forget that you should only consider the balconies in the autosplay operation this time. It's an excellent time to save our progress. Name your project, choose the preferred location, and click Save. When you save a project, system definition file used are saved with it, so you can pass it over to clients or coworkers without having to worry about missing files. If you perform any modification to a saved project, This little star appears, indicating that the current project contains unsaved changes. To load a project, just click File, Open. It's time to see how good our setup is. The best tool for this evaluation is mapping. Click Show Mapping to see it. When mapping is active, a color legend appears on the right, helping you interpret the results you see. You can hide it by clicking on this icon. The mapping legend can also be toggled in side view. Clicking on it will open the mapping colors page of the options window, where you can define a custom scale for your mappings. If you leave it automatic, as default, the scale will adapt to your current results. From the mapping toolbar, we can also set other options. On this drop-down menu, you can choose the type of mapping being displayed. Direct SPL Z, that is with no weighting, or Direct SPL A weighted. Weightings are ways of accounting for differences in the human perception of loudness at various pressure levels. Several types of weightings have been developed. However, the A weighting is the most commonly used nowadays. The frequency and bandwidth drop-down menus alter the way in which the mappings are displayed. The bandwidth can be either broadband or band limited to 1 octave or 3 octaves. Please note that mapping settings will apply to all calculation in ease focus, including levels, as well as distribution graph and frequency response, which we will examine later on. In this toolbar, we can also deactivate specific sources and areas, and even create sound source groups and audience area groups. Using this drop-down menu, deselect the delay systems. Then, on Manage Groups, choose Store Current Source Selection as a group, and label it Main Systems. Next, create a group for the delay systems. Select both left delay and right delay, and deselect the others, and store again with label Delay Systems. It is now easy to evaluate the contribution of each system, or group of sound systems. Inactive sound sources will display this black icon. We'll also create audience area groups. They are especially useful to evaluate the design results, and also when one area is hiding others. The procedure is similar to what we just did for sound sources. Try to create a group for the front areas and another group for the back areas. This is how it should look. We could also have created the area groups when we use the copy areas operation. For this, we would only need to select Create New Groups, and they would be automatically created. All SPL calculations in this focus are limited to the direct field. Also included in the calculations are area attenuation effects according to ISO 9613. Shadowing and ground or sidewall reflections are not considered. When performing a sound system design, the keyword is homogeneity, which means minimum variance over all the audience. Ease Focus 2 provides an important feature to evaluate the acoustic coverage of your project, the distribution graph. You can view statistics on pressure levels over all mapped points and see a bar chart that summarizes the results. It is particularly useful to help you meet the project specifications. You may want to optimize the coverage in a way that, for example, 90% of your audience is within a range of plus minus 3 dB. By default, the distribution graph shows you information about all the audience areas included in the project, even if some of them are not visible. But you can also analyze the distribution in a specific area or group of areas. For this, choose the areas you would like to analyze and make all of them visible. Next, on the distribution graph window, check Visible Audience Areas only. Calculation settings can be changed in the Options window under the Calculation Parameters page. The mapping resolution will affect the patch size of your calculation. That is, The higher the resolution, the smaller these little squares. You can select the type of input signal to be played from sound sources, and you can also choose the preferred calculation accuracy. The fast approximation will compute values with an internal resolution of 1/3 octave. The higher resolution will use an internal data resolution of 1/24 octave. Finally, we can add receivers to the project. They represent points of interest for the acoustical analysis. Where they are inserted, we can basically evaluate the system's frequency response. To add them to the project, just select the corresponding button, and then click or drag with your mouse in the top view. You can specify a receiver to be your reference by left-clicking on it in the legend. How do other receivers differ from it? Right-clicking on a receiver will toggle its visualization in the plot. Try to optimize the main and delay systems through their side views. After meeting the project specifications, you can finally export the results. One simple way to do this is by exporting pictures. Every window that displays a plot or a drawing can export a picture. You can do this either by right-clicking on it and selecting from the context menu Copy Picture to Clipboard, and then pasting it in any program, or by selecting Save Picture to from the same context menu, and then choosing the path where you want to save your picture, or from the main menu, File, Export Picture From, and then choose the window of interest. However, the easiest way to generate an overview of your project is the Create Report feature. A small window will appear asking which extra details you would like to add. Next, you will be asked for the location where you want to save it and which format you would like to use, PDF or RTF. The report is a document that contains all the details from its focus that you'll need to install your sound systems at the event location. Extended features are also available in its focus too, but haven't been included in this tutorial. If you feel comfortable enough with Focus basic functions, you can try to activate the extended mode from the Options window in the Environment page. Please refer to the Ease Focus User's Guide to learn more about them. You can open it from the Start menu, from the Focus main menu, or pressing the F1 key. You will need Acrobat Reader or another PDF viewer to read it. This concludes this tutorial. Thank you for your attention and have fun with the software.